All right, now let's do some Snell's Law problems. Please don't panic over these. I know they can be a little confusing. The easiest way to do these is to draw your surface, identify N1, N2. So this is the first material, this is the second. Go on and draw in your normal, and then show me your two rays, where this is theta 1 and theta 2. Now make sure your calculators are in degrees. I can show you how to do that. All the calculators are just a little bit different. All right. Now, to do these, basically what I want you to do is go on and plug the numbers in and then do whatever algebra you need to solve it. For example, a light ray of wavelength 589 nanometers, so that's lambda, is 589 nanometers. Now don't panic, you're not going to need it, but you have to write it down anyway. Traveling through air, so let's see, it's in air. So I know the index of refraction of air is 1. How do I know that? It's a given. Hits traveling through air, strikes a smooth, flat slab of crown glass at an angle of 30 degrees. So the angle through air is 30 degrees. The index of refraction of crown glass is 1.52. So index of refraction of glass is 1.52. So N of glass. You don't have to do the diagram. I just like doing it. All right. So here it's going to come in through air, theta air, and then it's going to refract somehow. Okay, so I'm looking for theta through the glass. So I know the index of refraction of air, sine theta air equals index of refraction of glass, sine theta of glass. Now, index of refraction of air is 1, sine theta of air is 30, equals 1.52 sine theta glass. That's what we're looking for. Now, let's see. Sine of 30. How do you do that? On my calculator, I type in SIN in parentheses, 30, close parentheses, and hit enter, and that gives me 0.5. It's 1.52 sine theta g. So I'm going to divide both sides through by 1.52. So sine theta glass is equal to 0.5 divided by 1.52. Or, now leave this in your calculator, but I'm getting 0.328947, blah, blah, blah. Now what you need to do is, to get this, the inverse of sine is your inverse sine. So find the symbol on your calculator that says sine inverse. It'll have a little negative like that. So it'll be minus second, blue, inverse sine, 0.3289. And I get theta g is 19.2. We'll practice this in class. Find the angle of refraction for a light ray that enters a bucket of water from air. Okay, so here we have air. And I like air because N of air is 1. From an angle of 25 to the normal. And I tell you that N of water is 1.333. All right, and I'm looking for theta in the water. So I know N of air, sine theta of air equals N of water, sine theta water. So 1 sine of 25 is equal to 1.333 sine theta of water. All right, the first thing you need to do is find the sine of 25 is 0.4226. I get 182. I got a lot of numbers here. Is 1.33 sine of the angle of water. I'm going to divide both sides through by 1.333. So sine of the angle through water is 0.42218 divided by 1.333. and I get 0.317. 04, blah, blah, blah. Okay, so I'm going to apply the inverse sine to 0.317, and I get the angle through the water is 18.48 degrees. A ray of light in a vacuum has a wavelength of 550 nanometers. Just going to write it down. In air. All right, so we know the index of refraction of air is 1. Enters a slab of transparent material. The incoming ray makes an angle, so the angle is 40 degrees with the normal, and the refracted ray, let's just call this theta 2, is 26 degrees. Find the index of refraction in the second material. All right, so this one's actually, in some ways, I think easier. So we come in at an angle of 40 degrees, and then we refract. N of air is 1. N2 is, we don't know, we're looking for this one. So N1 sine theta of air equals N2 sine theta 2. Now, because we're looking for N2 and we're not trying to do any transcendental functions, let's just go and divide through. So N2 is N1 sine theta air. We can call it N air. How about that? Divided by N2. Now let's plug our numbers in. N of air is 1 sine of 40 divided by N. Crud. I messed up. Y'all didn't stop me. Goodness gracious. Let me erase this. Okay, I'm solving for, whoops, sorry about that. I'm solving for N2, so I've got to divide through by sine theta 2. Now plug in your numbers. N of air is 1 sine of 40 divided by sine of 26. All right, the sine of 40 is 0.64. 2788 basically. The sine of 26 is 0.43. 837. Now divide these two numbers. And I get an answer of 1.466. One more problem. For each of the following cases, will the light rays be bent toward or away? All right. Now, let's go back to my diagram. I always go air. I always do air because this is always going to be the fastest. Always the fastest. And this is the end of my medium. And it's always going to be greater than 1. I always draw in my angle. And I know it always bends toward the normal. All right, so if Ni is greater than Nr, which of these is this? All right, so it's going to be going, hold on, let me do this one in red. What if I reverse my direction? Let me undo that. What if I reverse my direction? So now my ray is going this way. All right. This one is going from slower material to faster, or from N greater than. All right. If Ni is greater than Nr, then it's going to bend away from the normal. So theta r is going to be greater than theta I. If I'm going when Ni is less than Nr, that'll be the blue example. And then theta r is less than theta I, so theta r is going to be less than 20, where up here it's greater than 20. From air to glass, Oh, I'm asking is it toward or away? Sorry. All right. For the first one, it's going to be bent away. For this one, second one, it's Ni is less than Nr. Is that right? If Ni is less than Nr, would be toward. I have to figure these out myself. Okay. Okay. From air to glass. So from air to glass, it's going to be bent toward. From glass to air is this direction right here. So it's going to be bent away.